The objective of this lesson is I can find the volume of 3D composite figures. So we're going to put some figures together. So what I'd like you to try to do at the beginning here is find the volume of this prism. So start by pausing the video and finding this volume. Now that you've tried the problem, let's do it together. First, you got to look at these different bases, and finding the bases is critical to this. And if you see that these two triangles are parallel to each other, those are our bases of this figure. The other sides are not parallel, so you can't use them as the base. So the triangle base that we have has a base of 8 and a height of 6. So to find the volume, go 1/2 times 8 times 6 gives us 24 for this triangle. And then we're going to stick that into the volume formula. And because it's based on having base times height, the base on this being the triangle, the volume is going to be the area of that triangle, 24, times the height of the triangle, which if you notice between the two faces, it's 5 units. So it's going to be 24 times the height of 5, and that gives us 120 cubic centimeters. Let's do a little bit of review now of our volume formulas. These are the formulas that we talked about in the last lesson. And these formulas are very similar in how they look. So look for the similarities when you're using them. So for the prism, the volume is the base times the height. And the base of this one is going to be a polygon. And so when we do these problems, you're going to find the area of the polygon base, and then you're going to multiply it by the height, just like we did in the previous opening problem. Now the pyramid has a similar formula, only because it's smaller, because it comes together to a point, it's going to be 1/3 times the base times the height. And that base is also going to be a polygon for the pyramid. Now, when we do a cylinder, it's going to have a very similar formula to the prism. The volume is base times height, only this time the base is going to be a circle. The circle base is going to be what we find the area of first and then multiply it by the height. Whereas the cone just looks like the pyramid because it comes together as a point. It's going to be 1/3 times the base, area of the base times the height. And in this case, the base on this as well as the cylinder, the base is a circle. So notice that the cylinder and the cone both have a base of a circle, whereas the prism and the pyramid both have polygon bases. The sphere is different, so it's just a different formula I have to learn. It's going to be volume equals 4/3 times pi times the radius cubed. Since it's in 3 dimensions, it's going to be cubing the radius. Now let's talk about a new principle called Cavalari's principle. Cavalari's principle really says if we're going to lean a figure like I have for this cylinder and then kind of the lean cylinder, if they have the same cross section and the same height, they're going to have the same volume. So if two 3D figures have the same height and have the same cross-sectional area, so if you take a cross section, so cut it across the middle or in any place, those cross-sectional areas are the same at every level, then they have the same volume. So it doesn't matter if you take it and kind of lean it over like that. That leaning cylinder has the same volume as the one that stands up, as long as they have the same height for them. Okay, and in this case, the height we would just call an h. All right. So now that we've got that principle, we can use it. I'm going to do this next example, the volume of this composite figure. I'm going to do it 2 ways. I'm going to do it as a composite figure first, and then I'm going to go ahead and do it as with cross sections. Okay, so we're going to use the formula for this, just like the cylinder was base times height for the volume. So is this one also. We're going to do 2 separate problems. We're going to do the triangular prism there first, then we'll do the rectangular prism down below. Separate figures. A composite means you add those 2 together and you get the volume of the total figure. So the volume of the triangular prism, the one on top, we're going to take, again, base times height. You got to look for what are the parallel bases. Well, they're the two triangles on the front and the back of it. Those are the two parallel sides. So that base that we'll do to find the volume will be 1/2 times the base of it, which notice is a 5. You got to take that 5 from down below and move it up to the base of the triangle, times the 3, which is the height of it, and then times the length of it, which it goes along the distance there is 9. Multiply those together and you get 67.5. Now let's do the volume of the bottom figure, which is a rectangular prism. And that rectangular prism, notice that if we find the front face, actually that rectangular prism has all the sides parallel. So you could do, we're going to do the front face being that 6 by 5 rectangle on the front as the base, times the height of it, which is going to be in this case 9. That takes it all the way along, just to be consistent with the triangle. But again, since all the faces are parallel, opposite sides, we could have chosen the other base. Still becomes 6 times 5 times 9, which is 270 for that volume. Add those two volumes together to get the total volume of the figure, and you get 337.5 cubic meters for that volume. Now what I'd like to do is, now that we've done that using a composite figure, just like we did with area, of adding the two volumes together, let's do it instead with the cross-section idea. What I want to do is, since that cross-section doesn't change for the entire figure, it's a constant cross-section, we want to find out what the area is of one of the cross-sections, that triangle over the rectangle, and then multiply it by the height of it. So, and this height, again, is going backwards as the length of 9. So when we do that, we're going to find the area of the triangle on top of the rectangle. The area of the triangle on top has a height of 3 and a base of 5, and then the height of that rectangle is going to be 6. So to get the area of the triangle, we go first of all 1/2 times 5 times 3, which gives us 7.5. We're going to take that now and we're going to add it to the area of the rectangle. The rectangle is just 6 times 5, length times width. That gives us 30 for that. And if we take and add those two together to get the whole cross-section area, that gives us a total cross-section area of 37.5. Now, all we need to do to find the volume of that, since it's a constant cross-section through that whole length or height of it, is take that cross-section, 37.5, and multiply it by the 9, which is the height of it. So cross-section times height, and that gives us our total, in this case, our total volume. So 37.5 times the 9, that gives us a total cross-section volume of 337.5 cubic meters, which matches the other way we did it. This is just a different way to do it. Notice that the math is very similar in it, but you can do it as a composite figure or as a cross-section in this case. All right, let's for composite figures, we've got other ways, other types of problems. This next one has kind of a half sphere on top of a rectangular prism. So to do this one, we're going to take that half sphere, which is called a semisphere, and we're going to find it first, but we have to figure out what its radius is, because the volume of a sphere has the radius involved. So if you draw all the way across that semisphere, notice it's the same as the width of that rectangular prism, which is 6. So the radius of it is just going to be half of that. So the radius of our sphere is going to be 3. Now we take that 3 and we're going to take and find the volume of our sphere first, and then once we find the volume, we're going to take half of it. So volume of the entire sphere is going to be, we'll do the half sphere, but first we'll find the whole sphere and take half of it. So volume of the entire sphere is going to be 4/3 times pi times 3 cubed, which gives us a 36 pi. Now we only want half of that sphere, so we're going to take half of that value, and that will give us the semisphere volume of 18 pi. So taking half of that 36 pi gives us 18 pi for that semisphere. Now let's go ahead and do the rectangular prism at the, below that. The volume of that rectangular prism, notice since it's got a face, all the faces are parallel, so you could pick your face of it for which one's going to be the base. All it ends up being is, if it's a rectangular prism, then it's length times width times height. And so we end up getting 6 times 6 times the 10. And so that's going to give us a total volume of that rectangular prism of 360. Now lastly, all we have to do is take those two parts for a composite figure and add them together. And so you get the total volume equal to 360 plus the 18 pi, and that gives us a total, when we add those two together, of 416.5 cubic centimeters when we round to the first decimal place. All right, so that's how you do that composite figure. The next composite figure is a little different, because what I want you to see on this one is it's like a cone's been drilled into the middle of it. So if you see that cone in the middle of it, that becomes a hole in the cube that gets narrower. So to find this volume, we're going to find the volume of the entire cube, and we're going to subtract off that cone in the middle. That way we'll get the volume of what we actually have for this figure. So let's start by doing the volume of the cube. Volume of the cube is just, again, length times width times height. In this case, or any of the faces, is going to be 6 by 6, and then the height of it's going to be 6, so we multiply 6 cubed together and we get 216. Now let's do the volume of the cone, and we're going to subtract that off as part of it. The volume of the cone, remember that formula is 1/3 times base times height. The base on this is a circle for a cone, and so that's going to be pi times 2 squared. That's 2 is half of that 4. That's the diameter of that circle base. So we get pi times 2 squared times the height of 6. If we multiply that together, we get 1/3 times 4 pi times 6. And when we multiply that together, we get 8 pi as a total. Now, all we have to do to get the volume of our figure is to take the cube and subtract off that cube there, subtract off the cone, and we get the volume of our entire figure. So for the cube, we got 216. For the cone, we got 8 pi. And if we do that, we get an approximation of 190.86725588 on our calculator, and we'll round that to 1 decimal place. So we get it at about 190.9 cubic centimeters. So to do composite figures, you take the two figures and you either add them together, or in this case we subtract to get our final volume for the figure.